And here we are. The next thing that I'm going to be going over is rational expressions, which is in fact number 12 on your finals review. I know I skipped the page before, and I'm going to come back to it, but I want to make sure that I can get as many things up as I can now, and that was going to take a little bit longer to sort of prep things up. So what we're looking at when we talk about rational expressions is essentially dealing with fractions. So what I want to do to begin is to talk about how fractions work with adding, subtracting, multiplying, and dividing, because that's essentially all they're going to be doing. So let's do this first. Multiplying fractions. I think the easiest thing for us to look at is just an example. So if I've got 3/5 times, we're going to go with 10. Oh, I will make it ninths. The general rule when you multiply fractions is just to multiply straight across. So if I multiply straight across, we get 30 over 45. Then we can reduce that because they both divide by 15, and that's going to give us 2/3. Not bad. That's a general rule, multiply across. Problem is, though, is that what we want to be able to do is to try to try to factor out things that they have in common and cancel them out so we can get to the 2/3 without having to do any thinking. Because when we bring in variables, it doesn't work out as well. So I'm going to break all of these down into their component factors and see what's going to happen. Well, 3 and 5, both prime numbers, don't have to do anything about that, but 10 is 5 times 2, and 9 is 3 times 3. So that when I'm done with something like this, what I know is that there will be at the top of this 3, 5, and 2, and at the bottom of this 3, or 5, 3, and 3. So anything that there's in common that I could put on top of each other, they could divide out and just become 1. So I'm going to do that beforehand just to make sure that I can take care of this. So that would mean the 5 and the 5 will be on top of each other, so they'll divide out to become 1. The 3 and the 3 will be on top of each other. They'll divide out to become 1. So that means I'm left with just a 2/3, which is the same answer. It just gets us there faster. Now dividing, same general idea. It's just that when you do dividing fractions, if I start with, let's go 4/7 divided by 12/14. All I have to remember with something like this is that when I divide, I'm going to be multiplying by the reciprocal of the second fraction. So I have to set it up as a multiplication problem before I actually go into doing any of that canceling out of stuff. So if I'm going to do that, that means that I have to rewrite this as 4/7 times 14 over 12. Not that big of a deal. But now I can also see what we have that's in common. I know right now that 7 goes into both of these. Now I could write it out. This is 7 times 2, but essentially what I want to do is cancel out the things that are in common. So 7 and the 7 cancel out, leave behind the 2, 14's gone. I can do the same thing down here with the 12, because this is 4 times 3, so 4 and the 4 cancel out, I'm left with a 3, and then when I multiply across, I have a 2 and a 3. Hey, we got the same answer. How about that? So that's how multiplication and division work. Adding and subtracting, a little bit different, but not too terribly much. Actually, enough much that you want to think about it. If I add or subtract, the key that we're going to be dealing with for this one is that you have to find a common denominator. And so if I've got to find that, that's going to be the part about this. It's a little bit different. So I'm just going to go with saying we have, I'll do an addition. They function the same way. Let's go 5 over 12 plus 8 over 9. That'll be fun. I have to find a common denominator before I can add them. And so in this case, finding a common denominator, you know, in the world of dumb, is you just multiply the two of them together, but that number's too big. So we have to look and see if they have anything in common. Well, this is 3 times 3. This is 4 times 3. So what I know is that they have a factor in common. To find the next common one, I'm just going to have to multiply this one times something that the other one has that it does not. So this has a 4 and a 3. This is a 3 and a 3, so it needs a 4. This one needs another 3. But again, if we're going to do that, we have to multiply the bottom and the top of the fraction by the same number so that we maintain its value. Because if I multiply the top and the bottom by 4 here, that's like multiplying by 1. And if I multiply the top and the bottom here by 3, also like multiplying by 1 because we have 4 over 4 or we have 3 over 3. All right, anyways, so our new work here will be 15 over 36 plus 32 over 36. Now that they have a common denominator, all I do is keep that denominator at a 36 and add the two numbers on the top, which in this case, when I would be done, would give me a 47 over 36. Now, it's different than the multiplying, that there is not a built-in place where we can just cancel it out beforehand. Here, I'd have to actually simplify it, but I don't have to. 47 over 36 actually doesn't reduce. So what I'm going to say here is that is sort of our quick review of adding, subtracting, multiplying, and dividing fractions. Now, when we bring in variables, like we do for the problems on your actual sheet, there's a lot more going on here. But at its core, there's not. This is a multiplication problem. I should be able to multiply straight across. And I'm going to multiply across, but I want to see if anything cancels out first, which means I need to factor. And in order to factor with what's going to be happening here, that just means that we have to go and get all 4 of these to a place where we can have them factored out. This takes a while, and you have a billion practice problems on here. So what I'm going to do is just kind of take you through 4 of these and let you do the rest of the practice problems yourself. Okay. So here we go. And I'm just going to say it, and I'm going to kind of go through different things. The top one here, if I'm going to factor it, first thing that I see is that I've got an x to the 4th, which means I need to factor out a greatest common factor. So that means I'm going to have an x squared, because they all have that in common, times 6x squared minus x minus 1. Again, when we're in a situation like this, what we want to be able to do is to factor it out. So this is where we're going to be using the box method that you have been dealing with before. So in the case of something like this, I know that I've got a 6x squared here, I know I've got a negative 1, and I need these 2. So what I'm going to do for this part down here is to say I've got negative 1x up on the top here, I've got a negative 6x squared. So that means to me I am going to have a negative 3x and a 2x to get me to all the parts that I'm looking at. So we've got a negative 3x, we've got a 2x. If I factor these things out, I know that a 2 comes out of here. I know that a 3 comes out of there. So that means I'm going to have a positive 1 here, and I'm going to have a negative 1 there. So at the end of things, when this gets factored out, we end up with 3x plus 1, 2x minus 1, with an x squared in front of it. So that's a lot of stuff for that top one. I have to do that 4 times. Kind of makes you sad, makes you want to say, no, I don't want to do this. But don't listen to yourself. You've got to do it. Okay, so the next one, I'm going to just factor this top part here. And so I'm just going to do the box immediately because this is already something that is in quadratic form. So if I'm going to do this, that means I've got a negative 9x here, negative 10x squared up on the top. And so that is going to be a negative 9x and a 1x. No, it's not, Bechtel. That is BS. Negative 10x and 1x, because they multiply to that and they add to this. Gosh golly, here we go. So I'm going to put those here. And let's see what we can pull out. In case of this, I'm going to pull out a 2. Okay, so this is just a 1. So that means I'm going to have a negative 5 here and a positive 1 here. So this factor is going to be x minus 5, 2x plus 1. Solid. Okay. The bottom ones, here's the part that's interesting. 2 terms here, I'm just going to do this the fast way. You can go through these and put a 0 in the middle. It's almost always the same thing, though. There's almost always a difference of squares. 4x squared, that's a perfect square. 1 is a perfect square. And there's a difference, which means I'm going to have a plus and a minus, and the fastest way to do this is, because I know that these things will be conjugates and the middle terms will cancel out, this is just 2x times 2x. This is a positive 1 times a negative 1. So that gives me that one. I am going to have to do a little bit more work with this guy down here, though. So first thing I'm going to have to do is pull out an x. X squared plus 16x plus 5, and then I got to do the box. At least they're all positive. I mean, that's fortunate. So 16x, I got 15x squared up here. So we're going to have 15x and 1x. There's a lot of 1's in here. And I'm going to do some factoring. So here I can take out a 3. There's a 1. That makes this a 5, and that makes this a 1. So we're dealing with x, 3x plus 1, and x plus 5. All right, I'm going to put back together this craziness that we're dealing with here. So in doing that, we've got on the top x squared, and then I've got 3x plus 1, 2x minus 1. On the top over here, I've got x minus 5, 2x plus 1. On the bottom here, I have x, 3x plus 1, and x plus 5. And on the bottom over here, I've got 2x plus 1, 2x minus 1. Okay, so I've just replaced them with all the things that I've factored, and now is the canceling of the awesomeness. So I would just go across the top and see what I got. I got an x squared. Down here I have an x. So that means this cancels out, becomes a 1. This cancels out, becomes an x. So I just divided them both by an x. 3x plus 1. Hey, there's another one of those down here. Those are both going to cancel out and become 1's because they divide. 2x minus 1. Directly below, I have another 2x minus 1. Both cancel out, become a 1. X minus 5. No. I have an x plus 5, but it doesn't count because that's plus. 2x plus 1. Hey, there's another one of those too. That's a 1. That's a 1. So now, all I have left on the top is an x from here and an x minus 5. So I'm going to write that. X times x minus 5. And down on the bottom, the only thing I have is an x plus 5. So that's my final answer to that first one. Now, I'm hearing my dogs bark, which is not any of the needs that you have, but with people asleep. I'm going to stop this broadcast and come back to more problems in just a little bit.